Okay, let's finish up the section here. Get my calculator out of the way, and we just have a little bit of vocabulary here, and then some practice problems, basically, and then we're done. So the variance is the result of the summation and standard deviation. Okay, before you take the square root. So in other words, the variance is sigma squared. If I were to find the standard deviation, like on my calculator or something, then all I really have to do is take that standard deviation and square it, and I'll have the variance. So it's just another measure that we can use that describes what's going on in the data. And we just got to kind of be able to use it here. So obviously you can use a calculator. At this point, you should know that to find any statistic you're asked to calculate in this chapter. And obviously also calculating things by hand is just a tremendous amount of work, and you don't want to have to do that by hand. So just use your calculator and you'll get done a lot faster and probably a lot more accurately too. So what are the mean, variance, and standard deviation of these values? Well, all we're going to do is plug them into our calculator. So in a single list, and you don't even have to really label the list if you don't want to, I don't think, on your calculator. So we're going to type in these numbers: 6.9, 8.7, 7.6, 4.8, and 9.0. And 9.0 is the same as 9, so I don't have to worry about it. Don't forget to make sure that you're off of the cell. So press enter on that last cell to get off of it so that it actually registers. And now we're going to do our normal stat calculations. So menu, statistics, stat calculations, one variable statistics. As long as your cursor is still in the same column that you're entering the data in, you're good. So you just hit OK, and then OK, and there you go. So now we just have to find the information that we're looking for. So they ask for the mean. So we have X bar, and that is 7.4. Pretty easy. And then standard deviation. So we would scroll down if we needed to, but we can see it sitting there. It is sigma equals 1.5033. 4 decimal places is probably just fine. So now they want to calculate the variance. Okay, we can't do the variance unless we know the standard deviation. We know the standard deviation. So in order to write down like the symbol for variance, you just use sigma squared. And all you have to do is take that number and square it. So we go to our calculator and we type in 1.5033 and then square it and press enter. And there you go, 2.25991. And if you had to round it to the nearest whatever, then at that point you would round it. Probably the nearest thousandth, so 3 decimal places. And if you did that here, it would be just 2.260. And that's it. Pretty straightforward. So now on this one, the table shows the number of hurricane strikes in the United States by decade from basically when we started to record this kind of data. So from 1851 to 2000. What are the mean and standard deviation for this set? So it's not asking for variance here. That's fine. They just want the mean and standard deviation. So this is per decade. So not every 1 year, but every 10 years it's going by, okay? So then the strikes in like 1850 to 1859, or 1851 to 1860, however it is that they're recording it. So decade 1, that time frame, there were 19 direct strikes on the United States, okay, and so on. So that by the time we get over here to this 15, that's the 15th decade since 1851, so that's 150 years, so that makes it 2000, okay? And in that decade, 1990 to 2000, there were 14 direct hits on the United States. So that's what that means. So now the question is, what's the mean and standard deviation? So what it's asking for is, what is the average number of strikes, so direct hits on the United States per decade? And what is the standard deviation of that set also? So all we got to do is type this into our calculator. Again, on the calculator, you just need a single column. So we go to our spreadsheet. You don't even have to label the column, and you just type in those numbers. So let me go ahead and do that real quick. Okay, so they're all entered in, and you're looking at the bottom of the list. Notice that I did get the cursor off of the last cell so that I'm not going to get an error. And then I'm going to go over to the menu and statistics, stat calculations, one variable statistics once more, and then just we're going to hit OK and OK, and then we just need to go up so we can see the two statistics that we're looking for. They wanted the mean and the standard deviation, so I'm up at the mean right there. X bar is 17.6, and the standard deviation is sigma equals 3.518 if I'm rounding to 3 decimal places, okay? So the mean here basically means that every decade we can expect 17.6 hurricanes to hit the United States, according to this data, and this is real data. Now the last thing we're going to do is learn how to make a histogram. So a histogram makes it's like a bar graph, but we're just going to be placing X's on a number line, okay? So we're reusing the same hurricane data. So in a data list, every value falls within some number of standard deviations of the mean. So for example, if the mean is 50 and the standard deviation is 10, then the number 42 falls within one standard deviation of the mean, because 40 is less than or equal to X is less than or equal to 60 is the range of values within one standard deviation of the mean. What that means, because I know that doesn't make a whole lot of sense, is if I were to draw a number line and I have the mean and I put the mean directly in the middle of my number line, and then my standard deviation in this example is 10, okay? So what I'm going to do is I'm going to add 10 to the mean, and I get 60. That's one standard deviation, or one sigma, okay, added to the mean. So here's X bar. Now, if I take one standard deviation away from the mean, then I'd be at 40. Okay, so that is minus one standard deviation from the mean. So what I've done is I've created a range of values, okay? Now 42 on my number line would fall somewhere in here, right? It's sitting right there. And that falls within one standard deviation of the mean, because this spread right here is plus or minus one standard deviation from the mean. All right, that's the idea. That's what's going on in this paragraph right here. So now what we're going to do is we're going to set up a graph like what you're looking at here, a histogram for the data for the hurricane strikes. So the first thing I want to do is calculate the mean and the standard deviation. Okay, well, we already did that, right? It was 17.6 for the mean. Oh, that's not the mean. X bar is 17.6. And then the standard deviation was, what was it? 3.52. So we're just going to call it 3.5, okay? So just for the purposes of this, sigma is 3.5. Okay, so now what you do is you draw a number line. Hopefully straighter than what I just drew. You put the mean directly in the middle. So that is 17.6, and remember that that is X bar. So then what you're going to do is you're going to add sigma to the mean several times. So if I add one sigma to the mean, I'd be adding 3.5 to 17.6, and I get 21.1. Okay, now that is X bar mean plus 1 sigma, 1 standard deviation. I do it again. Okay, I add 3.5 to 21.1, and I get 24.6. So that is the mean plus 2 standard deviations. And I'll do it one more time. So if I add 3.5 to 24.6 one more time, I get 28.1. And that is the mean plus 3 standard deviations. Okay? Now we're going to do the exact same thing going the other way. So instead of adding standard deviation, we're going to take standard deviation away. So from 17.6, take away 1 sigma, and you wind up with 14.1. And that is the mean minus 1 standard deviation. Do it again. Take 3.5 away from 14.1, and you have 10.6. So we are now at the mean minus 2 standard deviations. And then one more time, take away the standard deviation again, and you're at 7.1. So again, that's the mean minus 3 standard deviations. So that's how you set up all of these histograms. You're going to put the mean in the middle, and then you're going to add the standard deviation 3 times, and you're going to take the standard deviation away 3 times to set up a number line like this. Now, the next thing you're going to do is you're going to actually plot all of these pieces of data that you have, okay, the best that you can. So we have first piece of data is 19, right? So we're going to go and find 19 on our number line. Now here's 17.6 right here, and then we have 21.1. So where is 19? So 19 is maybe right in the middle, right? Like here's 21, and then here's 20, here's 19, here's 18, okay? So 18 is going to be pretty close to the 17.6. 19 is going to be probably right there. So I'm putting an X there. Now 15. So we go to where we think 15 would be, okay? So here's 14.1, which means 14 is on the other side of that. So 15 is going to be the nearest it can be to 14.1. So I'm going to put an X right there. Now 20. Okay, so we have 21. 21 would be sitting right close to that. We know 19 is sitting right there, so I'm going to put 20 right there. Now 22. So here's 21.1. 21 would be on the left side, so 22 must be on the right side, right there. Now 21. We know 21.1 is just a little bit bigger than 20, so we're going to put 21 right there. All right, so hopefully you can kind of see how this works. We have 18. We know 17.6 is just to the left of 18, so we're going to put 18 right there. Now we got 21 again, all right? We had 21 once, and now we got it again right here. So we're going to go to the same X that we had for 21, and we're going to mark above that 21. Now the 13, so we go all the way over to, here's 14.1. We know 14 would be sitting right around here. So 13, I'm going to go just to the left of that and put an X there. Okay, 19. So remember, we already had a 19, so we just got to figure out where we put it. It was right there, because that's a 20 right there, so we put the 19 right there. Okay, now 24. So here's 24.6, so we go just to the left of that 24.6 and put a 24. All right, 17. So we have 17.6 sitting right here, which means 17 must be just to the left of that. Okay, 14. Did we have a 14 already? No. So we go to 14. Here's 14.1. So that means 14 must be sitting right there. Okay, 12. Did we have a 12 already? No. So we go in between 10.6 and 14.1. Well, just to the right of 10.6 would be 11. And we didn't have a 12 already. So that means that this must be 12. Okay, now 15. We did have a 15 already. It was sitting over here. So let's find the 15x that we put down. Here's 14.1. Just to the right of that must be the 15. So there's my 15x. And then 14. And we did have a 14 already. Just to the left of the 14.1 is the 14, so I put an X there. Okay, now all of the data is placed. So now what we're going to do is answer this question here. Okay, so the question is, within how many standard deviations of the mean do each of the values fall? Okay, so first of all, here's the mean. Within 1 standard deviation of the data is inside of that ring. Now, do we have all of the data falling within that? The answer is no. Obviously, there's stuff outside of it. Okay, so go out another standard deviation. So within 2 standard deviations of the mean is all of this. Did I cover all of the data? The answer is yes. So therefore, the answer to this question, within how many standard deviations of the mean does all of the data fall? The answer is 2 standard deviations. Okay? Now, if I had, I'll just put a X on here somewhere else. Okay? If I had some X out here somewhere, okay, then this piece of data does not fall within 2 standard deviations of the mean. Therefore, the answer would then be, since this covers 3 standard deviations, the answer would then be 3 standard deviations. So hopefully you kind of follow how that works. That's how you make a histogram. Okay? Now, actually, I did want to show you that the calculator will do this also. If you enter all of this into a single column, and you name the column, and then you make a scatter plot. Like if you remember how to make scatter plots from earlier in the year, you go to make a scatter plot. Okay, so let's do that. So you can see that I have entered in a single column all of my data, and I labeled the column, I just called it hurricanes, and I came off of the last cell right here, which is really important, as we know. So now I'm going to go and create a scatter plot. So I go back to the home screen, and data and statistics. So now I have all this stuff, and you can see some problems from other things. We don't want that anymore. We're going to click to add variable, and I'm going to make it hurricane data. Okay. So actually, when the calculator organizes that data, before you go to click to add another variable or make a box and whisker plot or whatever it is you're going to do, that stack of little dots right there is the histogram. If you look at what we're looking at on our screen over here, you see the exact same thing. And the nice thing is you can see the number line for where things fall, but the bad thing is you can't tell exactly where the standard deviation delineations occur. Like we have here 7.1, 10.6, 14.1. Those don't show up on the calculator. So you do need to do these by hand, but the calculator will kind of guide you into what the answer should look like in the end. All right, that is it for the section.